All right, all of the above properties, that's kind of what you'll watch in the video, extend to left and right hand limits. So specifically the direct substitution properties applies to left and right hand limits, and all of the properties that you'll watch in the video. Okay? So I now want to find the limit as x approaches 0 of the absolute value of x. All right. Okay. This is what people do. They say, oh, absolute value makes stuff positive, I'll stop writing it. I see that in students' work all the time. Absolute value makes stuff positive, I'll stop writing it. You can't just stop writing it. Okay? Now, let's give the definition of the absolute value. Okay? What is the definition of the absolute value of A? What's the absolute value of 4? 4. What did you do to the number 4? Nothing. You left it alone, right? What function leaves something alone? Just the identity function. When do you do that? You do that if A is greater than or equal to 0. Okay. What is the absolute value of negative 4? 4. Don't say you made it positive. What did you do to that number? You changed the sign on it. Multiply by negative 1. That works. You changed the sign on it. You didn't make it positive. You changed the sign on it. Okay. So how do I change the sign on the number A? I put a minus sign in front of it. That's if A is less than 0. So for example, if I said, what is the absolute value of x plus 2? If you want to, you could split it up into 2 parts. You could split it up to be, it's just x plus 2. Oh, I'm going to run out of room there. What's the absolute value of x plus 2? Well, it's just x plus 2 if x plus 2 is greater than or equal to 0, right? Does everyone see that follows immediately from what we did above here? Okay, so I'm going to start using this term, argument. The thing inside the absolute value is called the argument. If the argument is greater than or equal to 0, you leave it alone. If the argument is less than 0, you change its sign. What's the thing inside the absolute value? X plus 2. If the argument is positive, you just leave it alone. What if the argument is negative? What if x plus 2 is less than 0? What do you do to it? Don't say make it positive. Change the sign on it. Negative x plus 2. Everyone see what we just did there? I will test you over that, at least twice. I will find ways to test you on that. Now, if you want to, you could solve this inequality right here, right? X plus 2 is greater than or equal to 0. That happens when what? X is greater than or equal to negative 2, right? And when does this happen? This happens when x is less than negative 2. And that should fit, right? If I plugged in a negative 5 for x, I would have negative 5 plus 2, which is negative 3, and the absolute value of negative 3 is 3. That's the same thing as putting a negative sign. That's the same thing as saying negative 5 plus 2. What does that come out to be? 3 as well. Okay. All right. That's how you work with absolute values. Okay. So now let's do some limits with absolute values. All right. Let's show that the absolute value, let's show that the limit as x approaches 0 of the absolute value of x is 0. Okay. Well, I can't find the limit proper. I don't know how to find the limit proper of this problem. So what should I break it down to? What's that?
Approaching from the left and the right.
Let's approach from either direction. So let's first approach from the right. Of the absolute value of x. Now, what types of numbers am I plugging in for x? Only positive numbers, right? So now there's no ambiguity. Even though I don't know what x is, I know that it's positive, so I know how to take its absolute value. How do you take the absolute value of a positive number? Everyone say, leave it alone.
Leave it alone.
Very good. The limit as x approaches 0 from the right is just x, right? Now, this is very important. What did I do to make this argument? I've looked at the definition, right? I looked at the definition to do that. Did I just wish away the absolute values? No, I went to the definition and applied the definition to it. What is this function right here? It's a nice polynomial function. How can we evaluate limits of polynomial functions? With the direct substitution property. No work required. We just say that that's equal to 0. What did I do? I replaced the x with the limiting value 0. That was one way. We approached from the right. Now we need to look at the limit as x approaches 0 from the left of the absolute value of x. So what is the sign on the argument going to be? The sign of the argument, the sign of the stuff inside the absolute value is going to be negative. How do I take the absolute value of a negative expression? Change the sign on it. Okay. So this is equal to, in fact, well, that's fine. Limit as x approaches 0 from the left of negative x. What did I do? I just changed the sign on all of the stuff inside the absolute value. But what is the function negative x? It's a nice polynomial function. What can we apply? Direct substitution property. This is equal to negative 0, but what's negative 0? It's 0. Now, my question wasn't to find the left-hand limit and the right-hand limit. What was my question? To find the limit proper. Therefore, what's the limit as x approaches 0 of the absolute value of x? 0. How come? Because the left-hand limit was 0 and the right-hand limit was 0.